Record progress.
Question 8b says B moves from the original position along the circle in an anti-clockwise direction until the area OBC is equal to 9/2 square units. Find the shortest distance that B has to move along the circle for the above to occur. So here is our B. Let's remove this. Here is our B, and we are moving in anti-clockwise so that our area of OBC is equal to that. So let's assume that B prime exists somewhere here. And we will then draw out our triangle. OBC. Now the area of the triangle is given by half base times height. In this case, we'll let our base be equals to OC, which is the radius of our circle, and we have shown that before.
Recording progress.
Then, if this is our base, we are looking for a perpendicular height. So what we're going to do is we're going to strengthen out this line here, okay? And then our perpendicular height for this triangle will be that one over there. So that is H. Now to find H, we're going to have an angle here. So that angle is, let's give it a name, beta. We can see here that sine of beta will give us our perpendicular height over our OB, or our new OB, which is OB prime. And then we can say that our height is sine of beta multiplied by our OB prime. Now remember, our OB is still the radius, so it's still going to have the same value of the square root of 18. Now, when we substitute everything in, our area, which is 9/2, must be equal to half our base, which is the square root of 18, multiplied by our perpendicular height. So in terms of our perpendicular height, we'll substitute in that. So our OB prime is still 18 because it is still our radius and sine of beta. So we can then calculate our beta to be 30 degrees. But you will note that the beta is outside of our angle. We would want the new angle that exists between C, O, and B, which will then be, if we use the fact that these are in a straight line, so angles in a straight line gives us 180. We'll see that that angle over there will be then equals to 150. Now, with that in mind, we know previously that, so let's just remove everything to clearly understand. So previously, that angle over there was 60. Okay, and now it has changed from being 60 to being all the way to 150. So how much did it move in order for it to get to 150? It moved. So in terms of movement, it's final minus initial, giving us 90 degrees. So there was a 90 degree from where it used to be to where it is, so that our area is 9/2. So we are then going to therefore look for the shortest distance it had to travel along the circle. So we're looking for that arc here, right? This is then the circumference, part of the circumference of our circle. So what we will do is we understand that the circumference is given by the equation 2 pi r, but we're not looking for it. We're looking for a particular ratio, only that part there. So we would multiply it with the ratio of the circle that we are interested in. So we have 2 pi, the square root of 18, multiplied by 90 over 360. And that would give us
Recording progress.
6.66 units.